So, welcome back, students. Today we'll discuss about Module 10, Authentication Factors. So, we'll discuss about what authentication factors are, what Kerberos is, and how it works, what is single sign-on, how it is working, then what are the best practices to implement access controls, all those things, okay? And most of the topics in this chapters, like something you know, something you are, something you have, all these are discussed in the previous chapters. Okay, just go through the chapters. I will just discuss only the new things. Okay, these things we already discussed. Single factor authentication, then two factor. Single factor, either, okay, out of those three, any one. Something you have, or something you are, or something you know. Any one of these, okay? Two factor means we use to authenticate a client or a user with two factors, like out of three, something you have, something you know, and something you are, combination of two. Three factor in the sense we need all the three factors, something you know, something you are, something you have. Okay, with password, with ID card, with your retina, like that. Okay, or fingerprint. Now we'll discuss about Kerberos. Okay, what is Kerberos? We have a word file first. I'll discuss the word file first. See, Kerberos is a single sign-on network authentication protocol. Single sign-on means you can log into the user log into a system by using a username and password, and he can access to other resources with the same network without login again. Like I open my Gmail account. See, I will open my Gmail here. Okay. Once I open Gmail, I already give the auto username password. Okay. After that, once I give Google Meet. Okay. Google Meet. I don't want to enter the username password again. See, let's see. It will automatically open Google Meet. See, my login is here. Okay, I just logged in only once in Gmail. Then I'll go for, say, Scholar, Google Scholar. Also, I don't want to log in again. It will open my Google Scholar where our research works are published. Okay. Then I have Google Drive. Okay. Google Drive, like your cloud account. Okay. Google Drive. Open Google Drive. I don't want to log in again. Already the same login used. Okay. This is what single sign on. Log into a system like Google or Gmail. One time username password you should give. If it is already a record means okay. Then other applications will automatically open. Okay. If you want to try it again, just go to new incognito. I'll go for gmail.com. Okay. I will give my username password here. Rajesh. Okay. Password. Okay. Give me password. Now I logged into Gmail, right? Wait, let me skip these things, okay? Formal things. I logged in my Gmail now. Now I'll go back to Google Meet. Okay, let's see. Do I need to give the Gmail account again? Already open Gmail. Gmeet open. Now we go for Google Drive. Google Drive. Also, it's opens without asking username password. Then we have Scholar. Google Scholar also. Only one time I logged in, that also Gmail. Remaining all are applications of which one? Google. So other application they didn't ask me username password because they use single sign-on feature. Clear what I'm telling? Done. Word file. Okay. And this Kerberos has a session. Okay. Generate a session that allows authorized user to access server using ticketing scheme. Okay. See here, we have the client. The client want to access the file server. So the authentication, authorization, all things done by the Kerberos. We have a key distribution center. There we have authentication server and ticket granting server. These two things. Okay. First thing, the client authenticates itself by using authentication server. That is the one which authenticate the client by verifying the username password. After that, the client will get connected to TGS for tickets. By using that ticket or key, it will contact the server. Okay. And the word Kerberos came from the mythology. Okay, it's like a belief, old belief, with three dogs. Okay, there are three dogs there that restricts people from an area. So dogs, whenever we have dogs, they will not allow people to enter a particular area. Okay, so at home, if you have dog means they will just bark. Okay, and they will check the stranger means they will not allow to enter the home like that. Okay, same here for security purpose. The Kerberos is a best one. So that's why the image or the symbol or the logo for Kerberos is three dogs, which are focusing on different or different directions. Okay, they restrict people from an area, entering an area. It has three components. Kerberos, the client, yes, client, key distribution center with authentication server and TGS ticket granting server. Then we have file server. Okay, then we have some steps in your PowerPoint. We have this diagram. Okay, but I give an elaborated description. Okay, if you draw this also, okay, but I want to give more information. If you want to write a note, okay, 2 marks, you can write this. But if you want to get more information, I'll just explain in the Word file. Okay, the session begins when client sends a server access request along with the username details. Okay, so the client will send a request to the authentication server. You will mention the username also. Okay. And what does the request contains? The request contains the service requested, the username. So what the service requested? Kerberos ticket granting ticket. Okay. Then Kerberos version encrypted timestamp. All these things I will request. Okay. And this request will go to where? The authentication server. So they will make a request to the services for services from AS. AS is authentication server. So with username, so far the authentication server will do, authentication server will receive the request, verify the user details. Okay, verify whether the username, password, the client details are correct or not by having that hashing. Okay, the hash file will be there. From that, they will check the username, password, everything of the client is correct or not. Then the authentication server decrypt the request sent by client. So whatever request you send, the client send, it will decrypt it and verify all details. What service you want, what is the version of Kerberos you want, everything, and the timestamp also. What time they made the request. Okay, because I want to make sure that request is the current one, not the expired one. Okay. After verifying all these things, authentication server will decrypt that message and send back ticket granting ticket. Okay, ticket granting ticket encrypted with the key. That key is actually the symmetric encryption, yani the key shared by the sender, the client. Okay. So it will send back ticket granting ticket. See here, authentication server are verifying the client details, check the client request, decrypted, send back ticket granting ticket and client TGS session key. So for the client to contact the ticket granting server, we need a key as well as a TGT ticket. Okay. What does this TGT ticket granting ticket contains? It contains ticket owner details. Who has the ticket? Okay, client. Okay, the client username, the service requested, which service they requested. Then session key between client and TGS and ticket value. The ticket has a validity time. It will expire. Okay. So how do we know? For that, we need to mention ticket validity. Okay. What is the time? The ticket starts activated until what time we can use the ticket. That's what ticket validity. Okay. All this information is given in TGT. Now what the client will do, after receiving TGT, they forward that to TGS and a server access request to TGS. Okay, see here. The client will send the TGT tickets. Authenticate any. It's an indication that already it is being authenticated by the AS server. So that also they will send. And what the ticket granting server will do, verify the details, check the key, and they will send another ticket, that is client to server ticket. The client to contact the server with another ticket. No, that ticket along with the key, session key for client to contact the server. Okay. See, ticket granting server or TGS decrypts the tickets sent by client and returns the client an encrypted client to server ticket using a key. That's what I told now. Now the client receives the client to server ticket. See, the client will receive the ticket. What the client will do? Send that ticket, that is client to server ticket, along with the authenticator. It's already authenticated. I have the key, everything. That details sent to server. Okay. See, client receives the client to server ticket, forward to file server. It contains the ticket called as client to server ticket, which contains ticket on details like client username, service requested, session key between client and server, and ticket validity. Okay. This is the one we sent. Then what about the server will do? Server will decrypt the client server ticket and they will give a particular time for the client to access the server. Okay, so they will reply, okay, I verified everything, the ticket is everything okay, details are correct only, authenticated well. I will give you some time for you to communicate with me. Okay, during that time, the client can talk to the server, access the file, everything. This is what how Kerberos authenticates you. Okay, so username, password, everything verified by authenticated server. Keys are being given by the server and ticket carrier ticket. They all give some key for the communication to happen. Okay. So the Kerberos contains three steps: client authentication, client will be authenticated, then client service authorization. So what service you are going to get? Okay, how we authorize that? Ticket and server will do that. And client service request, the client can, after doing all this authentication and authorization, client can access the server. This is what the third one. Okay. Then so Kerberos is based on three systems. They have a KDC, key distribution center, this one. Then they have Kerberos ticket granting service. This is the ticket granting service here inside. They have authentication service. This is authentication service. Okay. They provide the ability for systems to communicate in a secure manner. Okay, we can securely communicate because they are giving that key. Everything is secured. Okay, and it has transparency. User is aware of what is happening. Security. It provides confidentiality, authentication, scalability. We can use it in small or big network. So small or large environment. Okay, environment, or some people call environment. Okay. Now, use of symmetry key and trusted third party for authentication. So here, the Kerberos is the one which perform authentication. Okay, it's a third party. See, they use a third party authentication via a shared key. Okay, so here third party means, see that symmetry key and asymmetric. Symmetry key means the same key used for encryption decryption. So here the client's secret key is used for encryption decryption. So both encryption decryption already always done by client secret key, and this key is used for authentication purpose. Okay, that's what mentioned here. Then, now what are the weakness in implementation of Kerberos? Brute force attacks. So somebody will guess, that's what brute force. Okay, try to guess the passwords, guess the key, and try to attack. That's what brute force. And key storage. Okay, all keys must be stored securely. So because you are keeping a centralized or third party authentication, okay, the key should be secured properly. Otherwise, no, the key once the key leaks, no, the user and server will be affected. Then Kerberos tickets are cached on user's computer system. So if an attacker obtained those tickets, he will impersonate the user. Okay, so the tickets are being stored in a system. If someone attack the machine and somebody gets the key, means they will act like a client or user and they will make the network down. Okay, then clocks must be synchronized to complete authentication. It's like that's why every ticket, no, there will be a validity period. If the ticket is used after a particular amount of time, the ticket is not valid. That's why the clock must be synchronized. Okay. Then after that, central server continuous availability requirement. Okay. The server should be always available because server is the one which do authentication, authorization, ticket getting everything. Okay. This server must be 24/7 available. Otherwise, they cannot authenticate or authorize the clients. Okay. Then requirement for host synchronization. There should be synchronization between servers. Okay, there will be multiple servers like authenticate server, ticket getting server, many servers will be there. Okay, they should be synchronized so that we should avoid downtime. Server should not go down. The site should not go down. Once the sites or servers go down, there will be no authentication, no authorization, no ticket granting, nothing. Potential single point of failure. So here the main problem is there is only one KDC. The KDC fails means nothing will work. The clients cannot authenticate or authorize, so they cannot contact file server. So this should be a single point of failure. Okay, be very careful when you're designing KDC. Okay, that's a weakness. Then when appropriate for business use, okay, the same thing which I discussed here in these steps. Okay, they are giving an example. Let's go through that. Then single sign-on, which we already discussed, an access control where the system allows a user to log into a system and gain access to other resources within the network by a initial login. Okay, I just told you I opened the Gmail account with username password. Then with that same username password, I without repeating the username password, I logged in different services like Google Meet, Google Drive, Google Scholar, everything. Okay, that's what single sign-on. See, the users authenticate once and access multiple systems applications. Okay, they mentioned examples. Then three common single sign-on configurations implemented within an enterprise. Okay, Kerberos. So here we use a trusted third-party infrastructure for authentication. Okay, so here authentication done by a third party. Like we have a Kerberos, we have an authentication server and ticket candy server. Cookies. So every machine we have cookies, right? So like assume I open a website. Okay, say Netflix. One time I'll give username password. Then after getting the home page, I keep on clicking movies. Okay, whenever I do each click, they will not ask me username password because one time you access the website or system by giving the username password, in that browser we have a small text file that will store your identity or session information with your with ID. So that session information will be enough to move between different windows in that particular system or server. That's what cookies. That's also one way of SSO. Yes or no? We open Netflix, we log in one time, then we have many movies there. We keep on moving from one movie to movie, different links we click. They will never ask you that username password again because the cookies will store all the session information and they will not ask you to log in again and again. That information they'll store in a text file. Okay? The session ID. Until the session is open, you can use those applications. Once you log on, you cannot access it. Okay. Then smart card or biometrics. So here, by using the smart card or biometrics, you can easily access the other tools of the system like email, communication tools, everything. Once you access one tool, by using that card, if you log in once or swipe once, you can use all other applications, okay, in the same system. Like I told you, Google service, okay. Then enterprise SSO means it allows credentials to be passed outside of the corporate domain or network. Okay, let's show an example. One employee has to log into different apps with different credentials. He log in with username details by swiping the card, but the ESSO translates that to different credentials for each app like email ID, employee number, etc. See here, one employee log in with into the network or system by using his card. Swipe the card, and then what the enterprise SSO will do, say in that company we want to log into different systems. Okay, EHR, there we need employee ID. PAS imaging, there we need your see email ID. Rostering, we need an active directory username. payroll, we need to show employee ID. Okay, every time you cannot give all these details. What I will do, what the enterprise user will do, they will translate. Once you log in with your card, swipe the card and enter your authentication done. Okay, enter your details and authentication is done means enterprise SSO will translate your account, your data into your authentication details into ID, email, actor, username, everything for different systems. That's what enterprise SSO. Okay. Advantages and disadvantages of SSO. Eliminate need for remembering multiple passwords. Reduce the amount of time. Okay, if you have SSO, no need to remember password or no need to enter the password many times. Okay, only one time enter, then you can access all services. Risk. If a attacker obtains initial password, he will know how to access all resources. Okay, that's what. Then advantage, ensure same password policy applied to all resources. Okay, so password policy should be applied to all resources same. If the employee leaves the system unlocked and is away, the employee has essentially provided full open access to all resources. Okay, so there is not there, you kept the machine open, everyone will access it. Okay, reduce the need for administrator to manage various accounts. Okay, so administrator job is now reduced. Centrally manage access along when employees leave the organization. Okay, remove all the access to multiple accounts at one time. So if you ensure employees cannot access accounts later. Okay, so once you are leaving, no, all accounts will be deleted. Multiple accounts at one time we can remove. No need to go for separately. We can remove multiple accounts at once so that the employees cannot access the accounts later. This is the advantage, disadvantages of SSO. Okay. Then last one, what are the best practices for handling access control in an organization to reduce the risk? Discover, identify all data on network. Okay, whatever data we have in the network, discover and identify. And develop the policies based on the risk associated with the data. Example, credit card and social security numbers can be stored only on an encrypted file. So what type of data you are storing in the network? Okay, if it is credit card data or your resident card data, Pataka data should be encrypted. Then place appropriate access controls on the data based on risk level. There are different types of access control, right? We have simple passwords, username, password, simple numbers. Then we have card swiping. Then we have retina scanning. Then fingerprint scanning. Based on the risk of the data, you will use the access control. Okay. Say software engineers access to code under development, but deny access to customer service representatives. Okay. So what are the controls we mentioned for each person depends upon the risk of data. Okay, coding people, they have access to code, but not for the customer service representatives. Okay, that's what. Continuously monitor and test the policies and access controls to ensure that a loophole has not opened. Always check that your policies are working properly, your passwords are strong enough, your that retina scanning system is working so that you should not give a chance for creating a loop in the system, hole in the system, so that everyone can access your system. Okay. And there are some case studies also mentioned there. I don't want to go for that. Okay. So this is what in chapter 10. So easy chapter. Only main thing is Kerberos, how it works. Then what is single sign-on. Then what is enterprise sign-on. Okay. Remaining things we already studied in chapter 2, 3 like that. So just go through that. Here we have to study only about Kerberos. What is Kerberos? How it works. Then what is the weakness in Kerberos? What is single sign-on? Then what is enterprise sign-on? Okay. Then some of the best practice used to across enterprises to reduce risk. Okay. That's all for chapter 10. Okay.